your HK for this one. HK for this one would be 2 comma 0, right? So your axis of symmetry will be x equals 2, the H, always.
Yep. And then the slope for that line would just be like 1 because it goes up and because it's an absolute value, it just goes up 1 over 1 like infinitely, right?
Actually, no, because we have to describe the whole graph. Let me watch. I can sketch this quickly. You shift the over opposite. Remember, we go over 2 here.
Yep.
And this is a 1, and the box can actually be applied here also. There's so many times you can actually do this, by the way, for many graphs. So it's like a 45 degree going both sides like this, but pretend they're actually perfectly 45 degree here.
So
Okay.
does it just have a slope of 1 or?
The slope though is, you see, it's where is it asking for that? Let me see. Rate of
It's
change.
asking it for
Rate of change. So the rate of change. Now, this one you can either say exactly or you can say varied. Here's why. You know what? Varied is for curvy graphs. I believe most often in high school they actually tend to only use like curvy and all like that. It's like polynomial. Yeah, the polynomial. But for this one, the slope, there's 2 of them. Half of it is it's cut in half right here. One of them it's negative, one is positive. So the slope should be technically, if I were you, I would be specific. Watch, I would write it this way. Why can't I erase it? Okay, there you go. I would do but this is too specific. Let me try it. First one coming from infinity all the way to 2 would be m equals to -1. But for you might have to state that for negative infinity all the way to 2, not including, and then you can get your m being +1 when it's 2 to positive infinity. I don't know whether I've seen that, in for my other students for Algebra 2 in the past even. Sorry, from what I can tell, but this is perfectly correct if you were to analyze it based off the graph. So, yeah,
No,
if
I
I were
totally
you,
forgot that it was
yeah,
-1, negative
yes. And what about
+1.
max and min? Yeah, what about max and min here?
Well, the maximum or the minimum, it would be a minimum, and it would
Yes,
be 0.
yes. The y value at equal to 0. Yeah, min. Yeah, you want to state that, and you can cross that out. However, it'll be min. Very good.
So do I have to put the y equals to make it like the correct
I
answer?
think you should, but
Okay.
if you were to just to put the value 0, you should be fine. As long as you don't put like the x coordinate, like the x value,
Yeah.
you should be fine. Yeah.
No, because I know for axis of symmetry, there's one test last year that I
Uh,
forgot to put all of like the x equals, and I got like everything wrong.
that
So
means this is pre-cal territory, because teacher in pre-cal, they don't actually accept just max and min. They will have to ask you this way. Now you can do this back and forth. I'm sorry, you can switch them around. You can say at x equals 2, max or min or max. This in this case is min equals 0. See that? That's how they do it in pre-cal, or y equals 0. But I think you have to state min equals 0. So, and then you can flip them. Min equals 0 at x equals 2. That's how they do it in pre-cal. So I think this is what your teacher was thinking for at the time when you
yeah.
missed something. So this is technically supposed to be how you do it in pre-cal. So min. Yeah, if you have min, you write min. If you have max, you write max. Increasing, decreasing. Okay. Let's try this again, because I think a lot of students have difficulty with this.
So for increase, I said it was increasing, and
Uh,
then it was just negative infinity, positive infinity.
for increasing, decreasing. For
I
this
don't know.
graph, no, you have
Yeah.
to split them again. So you have to look at it.
Oh, I do.
Yeah, but don't have to write the lines to split them, but you want to eye it. For increasing, now I would recommend you scan from left to right. If you scan from left to right, you notice that this is going down. I know the arrow is pointing up, but ignore that arrow entirely. Like ignore this arrow, that arrow. And if you're coming from left to the right, you have to do that in math in general. When you're analyzing the graph, you always, for increasing, decreasing, you always do it from left to right. So if you do it from left to right, you have to say, you notice what comes first is that it's going down, therefore decreasing. you have to write first. So decreasing from negative infinity all the way to 2, not including. Yeah, is that okay? Like, you see how it's going down
Yeah.
here? Down like that. And wait, let me, like, I'm blocking the graph. So yeah, it's negative infinity all the way to 2. You never bracket increasing, decreasing values anywhere, okay? So, and then if you were to continue on from 2 on, like I'm looking from 2 on, x value wise, you see that it's going up. Now ignore that arrow, but it's going up. Therefore, it's increasing from 2 to infinity. That means
Okay.
we may have to look at some other graph. If they ask for the characteristic, we want to look at it so that you can get it right. I think you're okay with domain and range, I think, right?
Yeah.
Yeah. So x in domain is all real or negative infinity or positive infinity.
Yep.
Range from 2, I'm sorry, from 0 to infinity. So range from 0, including,
Yep.
to infinity. This one you bracket because it's on
Oh,
the graph.
wait,
Yeah.
why would I put a bracket instead of a
Okay. So the
parenthesis?
reason why is because this time it's inclusive because it's the y. I think you're okay for range all the y values. So imagine you
Yeah, yeah.
from here on up, from here on up. So if the graph is actually situated exactly on the y value, like 0 at 0, you have to include it for sure. How about this? You can
Okay.
memorize domain and range as you can have bracket, you can have without bracket when there's an open dot. Range, domain and
Oh, okay.
range, yeah. That's when you literally looking at the enclosed dot or open dot. But increasing, decreasing, you never ever use the bracket. It's like the rule. You wanna you can memorize it, remember it for sure. And I think you're okay with x and y intercept, right?
Mm-hmm.
Yeah, vertex is good. Now, can we look at another graph where they asked for the characteristic?
Yeah.
Where is this one right here? Okay, yeah, let's do this quickly. I think you're okay graphing this.
So I
HK.
said the vertex was 4, comma 6.
Are you
Or
sure?
it's -4.
Yes,
Yeah.
-4, 6 for
Yeah.
HK. Very good. HK, -4. Let me see, all the way here, comma 6, all the way up here. So right there. Now here we go. I'm glad I'm working graphing this one because now you get to really see all the coefficient. You can use this box method for many graphs. Now, when the graphs get curvy, you can only do it one time. So yeah, I'll go ahead. I'll go ahead and refresh your memory for the reciprocal function. But this one, here we go. If you were to graph this quickly, you got your HK. Let me double check. Yes, and then the negative tells you to flip it down or concave down, flip down, right? So I'll write down.
Mm-hmm.
But then the way you do it, this when you flip it down, you account for the 2. Here we go, 1 2 box on both sides of that. Then you connect them. There it is. You can still do the 2 if and only if the line is straight. You can continue doing 2, and then on this side also, like rise 2 down, whatever, or 1 1. But I don't see that at all. So these are the 3 points on the graph. You can add on more. Actually, it's over here. Add on more if you want. There you go. But let me make it even neater.
I
2,
screwed up my graph because
2.
I put it at positive on accident, so I'm fixing
Oh,
that up.
oh. Okay, now you get to see. Yeah, now we get to actually correct that, make it right. So 2 2 2 straight
Yeah.
down, like that. So this is
No, I
it.
probably was just doing it like on autopilot and I just couldn't, I didn't think about it.
You have a lot. You have a lot to do. I understand.
Yeah.
So okay, are you okay? Make sure you have this down. The negative always flip the graph down as long as you remember your parent function. You know, the v shape or the shape of the original function. Then you're good to go. Flip it down. But the way you flip it down, account for the 2. That's a stretch factor. But the box method is actually applied like a lot in sketching in college. Students do this like all the time. They see it immediately. So yeah, and teachers tend to actually do that without telling the student. They actually don't teach it in general, but when the student asks, they say, okay, if you actually do the slope, you'll see that box appeared. That's how they answer it. But they never actually tell you in general. But they sketch it. You can see it when they sketch it, they show the points on the table, but they don't do all the points, but they sketch this point and this point immediately. That's how they do it. Anyway, that's why I think you should always look for the box that you can draw if it's possible. It's like 90 to 98% of all the graphs can be done, at least in the beginning. You cannot continue with the box in in the curvy graphs. Sorry, in the curvy graphs. Okay, so now let's talk rate of change. So again, the rate of change, here we go, is this 2 value. So, but it varied because of the graph. You have to see, like, if you go from left to right, it's going up. Therefore, the rate of change for the first half, negative infinity, all the way to -4. I put it on the bottom here. Now you notice I didn't use the bracket. This has to do with increasing, decreasing. It's actually interconnected. When you describe like where, you have to think increasing, decreasing. But I know domain also, but domain, yeah, it's kind of different because the domain of this whole thing is in negative infinity, positive infinity. But when you describe the characteristic, it's different because you have to kind of split it in half because of the way it looks. So the slope for first half is going to be +2. And then you can say that, hey, m equals -2 when it's the other side of -4, negative infinity, I'm sorry, -4 to positive infinity. So that's how you can do it. And I guarantee you, teacher will accept it. But I don't remember how this was actually answered based off my students, like writing. I think they fill it in. I never pay
Yeah.
attention to it, but
Okay.
I know it. Yeah.
I can check the answer key really
Yes.
quick.
Oh, yes. Yes. Oh, yeah, I should. I'm glad. Please, let's have a look. For the rate of change. Yes.
Yep.
So, yeah, what did they say?
They said they just said plus or minus, or
2.
yeah, plus or
Plus or
minus
minus
2.
2.
Yeah.
Same thing. If you split them, this is very detailed. The teacher will always accept it. You're literally describing where and where, and what is, what the rate of change is. So yeah, so I know it. So the other one's the same. You can do plus or minus 1 if you want. If you don't want to describe, okay, make it short. So because since the solution guide allowed you to not describe where, just go ahead and split them. Just go ahead and ignore the where part. Is that okay?
Okay.
Just do m plus or minus. Same thing for the other one, plus or minus 1. So there you go.
Okay.
All right. Now increasing. You want to try it? Increasing, decreasing?
So increasing is going to be
Or decreasing, however you want to do first. Sometimes you get one and
no,
yeah.
decreasing is gonna be negative infinity, comma 4.
Negative infinity, negative
Or
infinity, comma 4. Okay, scan from left to right. If you scan from left to right, is it going up right now? If it's going up, it's increasing. See that?
okay.
If you scan
Yeah.
from left to right, so it's ignore the arrows like here. Every time you look at or evaluate the increasing, decreasing intervals, you're gonna look like this. You're gonna be looking from, so it's going up when you look this way. It's going up. So that's increasing.
Oh, okay.
So
Okay.
what you said was the increasing part. So yeah, in negative
Oh,
infinity all the way
okay.
to -4, it's increasing. But keep in mind, you don't use bracket here.
Okay.
And then of course the other side of it is going to be decreasing, -4. Because if you continue looking, right, you continue looking this way to the right, left to right, it's now
Mhm.
going down. So imagine you continue looking left to right, it's going down. You see? It's like a
Okay.
hill. It's
Yeah.
like going up, down, hill. That means it's going down at -4 to in positive infinity.
Okay.
That's it. The main range, I think you're good. X and Y intercept, you okay? Set for X intercept, you set your Y equal to 0 and solve. And
Yep.
your
Or well, in this
or you
case, I
can
think it's
look
yeah.
at the graph. Or you can look at the graph. But to do it correctly,
Always. Yeah.
you make sure you account for the slope then, or the box. Is it okay? It will cut
Okay.
through right here. I think it's -1 for X intercept on one of them, and the other one is it should be -6. I don't know. I don't know that I can solve for it, but if you do the graph perfectly, you don't need it. Actually, I can
Okay.
try to look at it if you want. Three here, three here. Oop, it's not. It's -7 for one.
Oh,
One of them is negative
okay.
seven. The other one is -1. Yeah, that one is okay. But yeah, one is -7, one is -1.
Okay.
Yeah. You can solve it, but it's actually kind of fancy. You're trying to set the absolute value a function equal to 0. It's actually fancy. I think you may want to rely on your graphing if you can. Yeah, no kidding. I don't
Oh,
think. Yeah, I don't think you want to do the math because it's messy. Unless you're very confident with it. Like, where was that one that you were solving? Like the one that you were doing. Yeah, let me see if I can find it. The absolute
which one?
value, the absolute value problems. I think there's like a couple. Let me see. Is this the one? It has absolute value in it. So it's the same concept that you would do for the graph. Here it is. If you're actually having to show the x-intercept by solving, then you have to rely on this type of method here, right? Solving it.
Hmm.
If you want to see it, I can show it to you for the graph. But but if you have the graph and you need to and you're sketching it, I go with the graph. Forget solving it.
So, something else I want to cover is on my last test, I technically got the one, what's the thing that we covered? Cubic function
Uh-huh.
or
Uh-huh.
whatever that function was that we went over.
Okay.
I got it right, but they marked me down credit for not showing all my work, like with the graph thingy, the chart.
Oh.
So I don't know. I don't know if it's on
Oh.
paper, because if it's on paper,
Okay.
then
So
that's gonna happen again. But if it's online,
okay.
it's not gonna matter.
Okay. So what this mean is that you have to do the transformation table. Do you want to go over it?
Yes,
Yeah.
please.
Yeah. I mean, you have to do the transformation table. We can find one right now if you want, or we can make it up, or we can use
Um,
another function to do it. But let me double check here. If they're not asking, let me see, graph each ray and
like,
segment.
so the only thing is if it's online, it shouldn't matter. But
Yes,
if
it
it's
would
on
it should matter.
paper again, it
Yes,
might
that's right.
matter.
That's
So,
right. That's right. So what do you think? Is it going to be online or
but so the thing is, that's the thing with like all of the graphing ones. Like I knew how to do the charts at some point, but then I found out an easier way to do them
hmm
without
hmm
the charts.
hmm
So I just stopped using them. But for this most recent test, we had to do all of them, and they marked me down a few points for not showing all my work. And I don't know how to do that now. So
Okay, but we can just do it quickly. If you show a
okay,
little bit, I think you can get by. How about that? Or
okay,
you might be okay for all of it. But I think it's time consuming. So it's very bad, by the way, for what they're asking
yeah.
of you. It's very bad because a lot of
No,
students,
so
yeah, don't like doing it or spend too much time
normally
on it.
all of my teachers in the past like didn't care about showing work on tests as long as you
Right,
got the right answer.
right, right.
But
Not this one. Not this one. Okay, so would it be online or would it be on paper? Like maybe combination or what
I
on
feel like
final?
it would be more online
Okay.
just because there's so many topics and they probably don't want to grade a paper test for the final.
Okay, just in case then, maybe do one. Is that okay? Let's
Yeah.
see. Yeah, let's. I'll make up one because I can't find the qubit function, unless you
Okay.
wait. Unless I still have your paper from before. Let me see if I can find it quickly.
Okay.
Let me see if I can find it quickly. I yeah,
It
this thing
might
is
not have it on there. I only sent a few of things.
this is actually something. This is yours also
Yeah, yeah.
from my other student.
I think that's so weird that he has the same stuff as me,
I
just like
know.
formatted differently.
Yes, right. I think that you guys they have a file where they tend to rotate things. Sometimes they have a test A, test B. Yeah, I really don't know. They have, well, based off my students telling me this, like through the years, they have like different version and they'll flip flop it, but they tend to go by the particular policy or topic that they have to cover. And since in the same school, it's exact. but just the problem's going to
Oh,
have to be, shift around a little bit.
it's
Yeah.
just like in a different order. It's not like different problems.
Right,
Then
right,
it's just like his page 2 is my page 5 or
right,
something like
right.
that.
Here it is. Yeah, I know. Is this it right here? This is it.
Uh, or I was that one of those.
Oh,
Yeah,
this
that
one, yeah.
works. But I
But
was
this one, it
referring
says, yeah.
to.
This one is writing
Yeah.
the equation, but we can use it to do
Okay.
it if you want. Well, what about this one here? Writing the equation.
So I was talking about the one where it's like the two swoopy lines pointing away, but I mean the cubic function works too because yeah, I don't use the uh chart thing for that either.
Uh-huh. Yeah, it will work for all functions, by the way.
Okay.
If you want to see it, the absolute value also going to work. You mean like that? That's what I think. That's what you mean. Yeah, this one, right? Like the V shape. Yeah, it will work for all
Uh
of it.
oh, let me find the real word. The reciprocal function.
Oh,
That's what
yes,
I
it
was
will
looking.
work. It will work there also. Yeah, it will work
Okay,
there,
okay.
but it's very tedious when you do it. Do you want to see both of them? Uh, uh,
I think just one,
okay,
and then I'll
okay,
see how I feel.
okay. So, for example, let's pretend this one wants you to have a table, right? Like
Okay.
do a table, and everything else also. Everything else also, like your HK, your intercepts, everything else, range, domain, and increasing, decreasing, all that. Okay, so first to do this is that you have to see there's no way around it about parent function. You have to know your parent function because you have to have the base
Mhm.
table or the parent function table, and then use it to do the transformation table for the one that you're going to graph or use for. So, for example, this one you have to do at least, to me, it's one, two, three, five. While other ones may not. For example, five. But don't worry, you don't have to know exactly where they are. So here's the parent function of the cubic function. That's the cubic function. Parent function table looks like this. You would do something like this: zero. You don't have to be perfect. You have to have at least, I believe, at
Mhm.
least four. But for something like this that is symmetrical, you may have to do five. Negative one, negative two, one, two. So these are the fives. And then if you plug it into it, so imagine if you know your base, you don't have to graph it really, but if you plug it into it, you get a -8. Imagine -2 times -2 times -2. This one will be -1, it'll be 0, and it'll be 1, and then it will be 8. So from here, if you plot them, you'll get everything you need. At -2, for example, it'll go down all the way to 8. So ignore all those weird dots. At 2, it'll be +8 up there. So it's like it's going to sketch this curve for you. Now, the transformation. Now, if you were to do this one, right? Now,
Mhm.
they're not going to give it to you like this, though. I think they're going to give you the actual function, right? You know what I mean? They're going to give you the actual
Yeah.
function. So we came up with it. So let's have a look. I should write it here. I'll write it down here so you can compare. Y equals, actually write it right below here. Y equals to 1/2 x plus 7 to the third plus 1. Okay, to do the table on this one, here we go. This is why it's tedious. All right, let me see here. Oh, it's another table, but the way you describe the table is like this. Your x inside, like in between the parentheses, it's going to likely be that, or if it's absolute value, it will be between the absolute value bars. The way you
Okay.
do is that the x column, the way you write it is the opposite again. It'll be x minus 7, like that. The
Okay.
y, it's actually not bad either. Now, this is as easy as that. The X column, I'm sorry, for the transformation table is going to be opposite, like X minus 7. There are fancier stuff, but you don't have to worry. They're not going to give it to you yet. Like there's something in front of the X that changes everything. But right now, just that. If for every single function, if you can identify the X being in between or in the between, like the parentheses, go ahead and write the opposite
Uh-huh.
like this. Now, the Y, you have to think this way. This whole chunk is actually the main chunk, since this is the main term for the parent function. Could you tell? They're kind of like
Okay.
related to each other like that. So therefore you eye that, and then what you do is that you might remember this now. You're gonna do
Yeah, yeah,
one
yeah. Wait.
half
One
y, one half
y
y
plus
plus
one.
one. There you go.
Okay. Yeah, yeah,
That's
yeah.
it. And then all
And then
yeah.
you punch in the numbers from the. Okay,
Exactly.
okay,
Then you
okay.
do, let's do a couple here. For example, you do 2 minus 7. It'll be,
But aren't
oh,
the numbers you use for the different functions like different in the parent function
yes,
chart?
yes, that's the only
Oh,
thing that you may have, but we can review it quickly if you want. I'll do the reciprocal right away. You want to see it?
okay.
Yeah. But yeah, you're right. You're absolutely right. So here's negative 2
No, because
minus
I just
7.
remember way too many numbers to remember, and I was
Mm-hmm.
really
Mm-hmm. Mm-hmm.
overwhelmed
That's
trying to
that's
memorize
why
all
that's
of them.
why that's why it should not be in pre-cal. The most teachers do not care in pre-calculus for sure. 90, I don't remember even one time now that the teacher actually cared for this table ever for pre-cal. But I've had students like way back that they still having to do it, or I might have remember it wrong. They did it because they remember to do it, not that they were required to do it. So I really can't say. But from what I know, they don't care in pre-cal. Here, you see how I did that? I put in the x and the y. You got to do it for all of them into the new transformation table. Is that okay? So you remember
Yep.
that, right? Okay. Now let's review the, the reciprocal function. I'll bring back I'm gonna go back to that graph. Okay, yes. Let me see. This one. I'm sure there's a better way to look for them. Here, let's do this one. Yeah, let's do this one. Okay, so the reciprocal function, this is the parent function. The table looks like this.
Okay.
Okay, so the value that you'll be using would be this. Uh, but let me graph it a little bit so you have an idea why. So here's the parent function of the reciprocal function. It's a box of one, and then asymptote right here, and asymptote right here, and it goes through that corner of the box, taper, taper around all the axes, both axes here, on both sides. And there's another box right here. So this is the only box that you're allowed to do when it's curved. Like the one is this one here. If you
Yep.
let me write it, yeah, that one up on top here. So this one is that box, those two boxes. But yeah, you got to draw them
Mm-hmm.
with respect to the HK. Okay, so if you were to graph this, it's something like this. You can do 3 here. Oh no, you cannot do 3. Sorry, you have to do 6. I think it's 6. Let me see. Okay, I'll do 1 here for sure. But how am I? Let me see if how I do it. I'll do right in the middle here. So you might need more space. I'm trying to pretend here. I'll do like right here. So the first x would be 1, and then your
Okay.
y will be, if you plug it in, 1 divided by 1. Imagine you plug it in here. The x, the, it's 1 divided by 1. So if you plug in -1 right here, it'll be -1. You see it? It's like over here too. It's okay. Like your x is
Okay.
being -1 right here. Okay, now let me think. Yeah, I think you have to do 2. If you do 2, I'll going up. If you do 2, it'll be 1/2. You see why? Because if I plug it in right there,
Mm-hmm.
when x is 2, then I'll do
Oh,
then I'll do
yeah.
-2.
Okay.
Then I'll do -2. It'll be -1/2. Now, if you do 3, I think this is it. I think you can stop 3 and -3. Then it'll be 1/3. Then it'll be -1/3. That's it. Then you do the transformation table based off these values. Why this is tedious? Can you see why? You deal with fractions. You see, Carmen, this is bad. This is
Yeah.
bad. Why? That's why I'm like, do you have to do this? Yeah. So now imagine you doing it for this graph, this function here. Let's see if I can erase this. Oh yeah, I could. Nice.
No, so the thing is, like all other tests I took, I never show work, and I'm like notorious for that, and I never got marked down credits. I
Yeah,
was like, oh, it's probably fine.
I
And then
know.
this time around, they're like, nope, you got to do the chart.
Yeah, man. That's not good because look at this.
It's really
Look at that.
annoying, yeah.
Yeah.
That
Yes.
no, so my teacher, she's a student teacher currently,
Mm-hmm.
Like we have a real teacher, but she's not allowed to like help out because
Mm-mm.
she's a student teacher. And more often than not, the student teacher like is like, "Okay, we're doing cubic functions now. I don't know how to do this. Go to the
Uh,
boards and do your own work."
mm-mm.
And then
Mm-mm.
we'll get presented like one of these charts or something, and I'm looking
Mm-hmm.
at it and I'm like, "What does this mean? What is happening?" And they
Um,
don't explain it, and it's really nice.
there sometimes the teachers themselves may not remember to do it. That's why they just tell you guys do it.
Oh,
Yeah,
so
this happens when, especially with substitute teachers too. Yeah, even the even the teacher themselves. No, no. Yeah, if the teacher's directing you to do it, then they better know how to do it. Okay, look at this one here. Here it is. You want to see it right now? We're going to use it on this graph, this reciprocal number 76. So we're going to do it on this. Do you want to see what it looks like? Have a look. I'll bet you know it. So here we go. I'm going to do a table for this one, okay? So let me make sure it's
okay.
clear here. So the transformation table for number 76 will look like this. For the x, same thing, x minus 3. Can you see? Just by looking at it. Yeah, this represents like the dependency, like grouping them. When they're next to the x immediately, that's you do the opposite, just like that. Is that okay? X minus 3.
Okay.
Now the y is it's easier than it looks. It looks kind of fancy, but it's not. The main chunk the main core is right here. It's like the 1 over x is right there. That's like the parent
Okay.
function. Therefore, it's just going to be negative y plus 4, just like that. But you can't see that plus 4 because I can't
Okay.
erase the background. Yeah, it'd be y plus 4. Let me write it over here. Just like that. I'll put it right here. So the transformation table would be x minus 3 because of this right here. Okay, x minus 3. And then the y will be negative y plus 4, just like that. Yeah, and then you
Wait,
start,
okay, okay.
yeah, then you start doing your math, which is no one wants to do. So it'd be 3 minus 3
Yeah.
for those 3, 1, if you do 3, and then the 2 minus 3, 1 minus
Okay.
3, negative 1
Well, once
minus 3.
if I memorize these chart things, I think
Uh-huh.
I'll be pretty good.
Yeah.
But
If you don't have it
yeah, okay,
down,
that makes sense, but like it seems really annoying to do it.
yes. Yes. Yeah. Here's like this one. I don't even want to do it. Watch. Negative 1/3 plus 1. And imagine the rest of the fractions. Yeah, and negative, not just that, it's a negative 1/3 way down here, negative one
Oh,
third.
it's a negative, negative.
Right? Right?
Mm.
Yeah, negative 1/3. Be careful with this negative. It's independent from the y entirely. The y in the parent
Oh,
function
really?
has a negative. Yeah, yeah. Is that okay? Like, look, if I were to come down here, if I were
Yeah.
to use this one right here, it's the negative 1/3, right? Right there. Therefore, it would be
Mhm.
minus 3 here. One minus. Oh, is it? I'm sorry. No, let me go ahead and do it correctly. Forget this one. Pretend I'm using these coordinate x comma y right here. It'll be a negative 3 minus 3, and then negative of negative 1/3 plus 1. You see it? Because this is negative 1/3 right here. So careful how you put this, yeah, how you plug in. If
Okay.
they come with a negative and they have a negative, you're going to have to do both. Yeah. So,
Okay. Thank you for going over that. I
yes,
really
of
wasn't
course.
expecting him to mark me down for that.
Yes, of course. Now you will never. I'll point this out. You will never have to do for the piecewise. How about that? Don't do. You
Oh,
have.
really?
Yeah. Don't ever bother because there are 3 pieces you cannot
Piecewise
do.
isn't really
Yeah.
gonna be
You cannot
annoying.
do 3 pieces for a transformation table. So because it's random, they made this thing up. So you don't have to do that. So keep that in mind. So don't even bother. Yeah. Or parabola. I think you're okay, right? For the y equals x squared. You okay? The parent function. Just make them as simple as. Like the parent function, make them as simple as
Negative
0,
two.
1, yeah, 1, 1, 2, 2. That's it. Negative 2, like that. And then just plug in, it'll be 4 here,
Okay, okay.
1 here, 0, and then 1 again, and then 4
Is
again.
that the same with the absolute value one, or is that
Yes,
different?
yes, it'll be the same.
Okay.
Yeah, but be careful when you plug in to use the absolute values to
Okay.
compute, to simplify it, right? Yes. So you gotta use all the bars and all that. Yeah. So
Okay.
yeah, this would be a perfect table for the absolute value one. Y equals absolute value of x. Is that okay? Also, not just for the
Mm-hmm.
x squared. for both x squared and that. Yep. Okay, I think you got this. I think you got this. If you need to do it.
So
Yeah.
there's one thing I was wondering. I was doing number 43. That's like the stuff we were covering last week, and I was finishing that page because we didn't get a chance to.
Mm-hmm.
I don't know if I sent it.
I'm sure. Let me see.
Might have been the ones I forgot.
What is it? About?
43, it's page 4. It's complex numbers using factoring, completing the square, and quadratic formula.
Yes, I have it. Let me see.
Somewhere because we did it last time, but
Right.
I don't know if I sent it.
Yeah,
Don't think it's there.
it's let me see one of these here. This right here, right?
Uh, yeah, I think so.
Okay, which one?
43. I don't. Oh wait, it's one off.
43. I think it's oh, yeah. Let me see. So a continuation
Uh,
of that.
I can
So
just read you the problem if you want.
let me see.
It's not like it's really
But
crazy.
it's still under the same instruction, right?
Yeah.
Okay, tell me.
So it's y to the third power minus 125 equals 0.
Okay, so we have to
So
follow.
I was doing it and I did the like one parenthesis with the two numbers and then the other parenthesis with like the three numbers and like the a squared minus ab plus b squared. But then I
Yeah.
didn't really know what to do from there.
Yes. I see it. I know it. Yeah, I know it because that. So you're using the difference of cubes and then how
Yeah.
to continue from there. Okay, yes, you're right. You have to actually continue for the trinomial. That one is the messiest one. Okay, let me see. I think you know how to do the rest. So I'll go ahead and factor right away. It's going to be now. This is going to be 5 cubed. Is that okay? And y cubed.
Yes.
So that means it's y minus 5. Factoring this and set equal to 0, and then you have y squared plus, double check my math here, it should be the same here, 5y plus 25 equals 0. This is what you got. Let me double check everything here.
Um,
Yeah, if you
I got
factor
minus 5y, but that could have
minus
just been
5y,
me being messing things up.
let me see. Do you mean like right here or right here?
Yeah. No, right.
Like right here.
The first one.
Okay,
Yeah.
watch. Let's see the formula. So it's a minus b. This will be the same, and then a squared plus ab plus b squared. The soap.
Okay.
I think you guys use soap. Same here.
Yeah.
S opposite here, and always plus
Okay.
AP, always plus here. So
Okay.
if don't forget, I'm coming from here. Okay, I'll write
Oh,
it. Yeah,
that makes sense. I didn't understand the soap like thing ever, and I was like, "So, what does that
yeah,
have to do with anything? What does
yes.
that even
So
mean?"
I know I actually learned from the students, and I have this memorized, for a long time. I just learned it from you guys. I'll be honest, like a couple
Yeah,
years
no, my
back.
teacher never covered that. So
No,
I was just like, "Okay, yeah,
yeah.
soap, it's part of this."
Yeah. So therefore, this is the same, the S right here, and then opposite here, like O for opposite, and then always plus here, AP. You see? Same,
Okay.
same. Yeah, so it's going to be S for this one. Now, if you want to see exactly the how, let me see, how do I write it so that you can see exactly? Do you see it this way or no? Because it's coming from here, like the
Uh,
original here. See, it's coming from here, like this is the original.
yep.
Ignore the 0 here. Therefore, if you
Yep.
if you factor it, there has to be S, the same right here. Imagine I write it to the
Okay.
side.
Yeah.
Yeah, write it to the side. Oh, I know how to do it.
Okay, I get that now.
Okay,
Yeah, I
good,
get
good,
that
good.
now.
Yeah, here. Yeah, I can write it right here.
But
But I'll write it as a 5 to the third there. So it's same right here.
okay.
You see it? Yeah, and then it's equal to 0 in the
Yep.
back there. Yeah. So from here, you set
I do.
each one equal to 0. The first one is done, like y equals to
Okay.
5. I think you got that. Now this one,
Yeah. Yeah, that makes sense.
keep in mind again, if you're using the cube, the sum or difference of
Yep.
cubes, this is not factorable. The last three, so don't do it by hand. So keep that in mind, or write it.
Okay.
Yeah, write it down. Not factorable. The This right
Okay.
here, the last three. Therefore, you are forced to use quadratic formula right away. So it's A, B, and C. Why are you doing that? Because you know how to deal with imaginary number, because it can happen in here. It doesn't always happen, but it does. I say 50-50. It can have imaginary answer like I in it. Therefore, you have to actually use quadratic formula. Okay,
Okay.
that's my C here. If not, it will be just a rational answer with a root. But okay, let me back it. So here we go. It'll be y equals negative b, which is 5 plus or minus b squared. See here, 5 squared minus 4 times a,
So
which
you're
is
saying that whenever there's the like, I always forget terms of everything, but when there's like the three parentheses for the soap, you have to quadratic formula that to get
every
the
single time. Yes,
zero.
yes. Coming from a cubic,
Okay.
I know, right? Coming from a cubic factoring. Is that okay? Like a third power
Yeah.
problem? Yes, yes. Always. Yes, you cannot solve that by any other way.
Okay.
Yeah, you can complete the square, but don't do it. A choice between completing the square and quadratic formula. You should, yeah, use quadratic
Okay.
formula every time. So this is and 2 times 1. So A, B, C. You have the quadratic formula down, okay?
Yep.
Right? Okay, good. So this should be it. So simplify it. I'm gonna do a little bit of, because I don't write all this in here, so I'm gonna write it outside here. So it'll be 25 minus 4 times 100, right? Yeah. So it's going to be, here it is, your imaginary. It happens like 50-50. I think probably more than 50. If it's not, it's just going to be a root problem that you can't simplify it. You know, like a root of 49. I'm sorry,
Okay.
not root of 7, root of 11, and that's it. No negative. But this one has a negative, and I expected that to happen, by the way. It's 75. So this is what I got so far, but you have to continue over 2. Yeah, you can, okay, from here, it obviously it's going to be an I coming out of it,
Yep.
you know, because of the negative, so it'd be I, but a root of
So,
75. What do you
oh,
think?
I was about to ask if do you put the I before or after the plus or minus?
You have to put it behind the plus or minus. Yeah, like you see it.
Okay.
Yeah,
Okay.
yes. It's like in front of the root, immediately in front of the root, immediately in front
Okay.
of the root symbol. Yes, and then the root of 75 is the same thing as root of 25 times 5. You see it? I'm
Okay.
looking at this portion now. So a root of 75 that I have left to do, I'll write it if you want, like this, over 2. But you can't stop there. Actually, if this 75 were other number like 11 or a prime number, it's not factorable with a perfect square number in it, you're done. Just so I just wanna, okay, I'm glad I wrote that just in case. Now, if you continue with this one, because it's you can rationalize it, you can simplify it further. It'll be 5 root 5. Can you see why though?
Okay.
It's a root of 25 times 5.
Yes, because there's a pair of five and
Yes,
one five
exactly.
left over.
Exactly. So now you can squeeze the eye, right? Still keep it in front of the root. So here's the final
Oh,
looking
okay,
answer,
okay, okay.
and over 2. That's it. Now, had
Okay.
this 2 been a 5 or a 10, you have to simplify it further. Do you want to see it? But you're done on this one, as long as I did everything
Okay.
correctly. Yeah. So this would be
No, yeah,
the
initially I just put five as the only answer because of that. I'm
uh,
just gonna ask Joss.
yeah. So yep, that's why you can see you cannot factor that three term there, the trinomial. Yeah,
Hmm.
so you have to do quadratic formula always. If and only if you're setting it equal to 0. Is that okay? It has to
Okay.
come. Yeah, it has to come from an equation. So you don't want to continue factoring. If you're just factoring, you're done right here. Have a look, okay? If you're just factoring,
Okay.
you would be done right here. But if you're solving, you have to continue all the way further.
So I think this section that we're going over, the completing the squared,
Mhm.
quadratic formula, and factoring, like that might be the hardest. Or the simplifying like complicated fractions only because I never like complete the steps. There's usually like one last step that I forget or something.
That that reminds me. Then you're talking about steps. How's you're completing the square?
I think I get it. I
Okay.
tried doing one and it made some sense. Like I knew what I was doing. I didn't know why I was doing it, but I was
Okay.
doing
Okay.
something.
Okay. Yeah, as long as you think you're okay. But don't forget,
Okay.
you only want to pick completing the square if and only if your coefficient, like the front number of the x square or the y
It's
square, being 1. Is that okay? Don't pick
okay.
any other ones because yeah, you, you need you need to do more if you pick that one.
What else could I go over?
Here, this here, we didn't go over this together.
I thought we did.
Um, uh,
We went over the or and for like a brief second.
but I didn't actually. Well, I didn't do it from scratch and align where they
Oh,
intersect or where you keep the answers.
okay.
Now it's up to you if you think you're okay. If you want me
I think
to
I'm okay
summarize
with
it, yeah.
those.
If I want to summarize it,
After
the
you,
or. Oh, sorry. Go ahead.
after,
Yes.
no, sorry. After you explained the or and last time, I think I
Yes.
get it, but I
Okay. Okay.
could get another or and explanation.
Yes, like yeah, the or it basically all the answers just keep them. The and is where they overlap, like intersect. But you graph them. I hope you graph. You got to graph. You got to graph 1, 2, and then
Yep.
align them. You know, or look at them at least for the or and all the answers. But the and you have to align them. You have to graph them on top of each other, and you have to see where they intersect. That's all. And then you could finalize it here. Is that okay?
So I remember last time when we were doing it, um, what's the word? You said it was uh infinite real numbers, or so that might have been on the answer key.
No,
I don't know, but you
I'll say
can.
this.
It's not, right?
The and can be infinite, but not from this number two, though. I don't remember it being that being the answer.
No, from number one, I mean.
Yes, number one, yes.
For number one.
Even number
Oh,
two with the and can have infinity as an answer. It depends how
oh
the graph
yeah, yeah, yeah.
looks. Yeah, it really depends on how the graph looks. But but often not. They kind of like cut off for number two. But yeah,
Okay.
system of
Yeah,
equations okay. System solving systems of the
yeah.
equation.
Yeah, you went over that, so it wasn't
Okay,
just only
good, good, good,
subtraction, and I actually understand what I was doing.
good, good. Piece of
Piecewise function, I reviewed those a lot, and I think I get them now.
okay, good, good, good. Word problem. Word problems. I hope you're okay with these
I
here.
want to go over those again.
Yes. So
Can we do a
now,
quick review?
yes,
One
I did it
more?
out of order. So let's pretend we do this from scratch. Is that okay? Ignore everything here.
Okay.
So you're gonna get one. I think both of them, but they're gonna word it a little bit different. I think yeah, at least one. But again, the wording,
So
the
I
numbers are
did
different.
write. I
Yes.
sorry. I did write the 64 through 67 as an example on my note card, but can you like explain this one again?
Okay. Yes. Let's do it in the order they gave you. 64 says, okay, let's
Okay.
start from the story here. You have hired a contractor, blah blah blah. But here we go, starting right here.
Okay.
Someone charging, here's starting right here, charges, this company charges 300 for the first hour. Okay, so that's like when they say something like that, it's a fixed price. Okay, another way they can ask you
Okay.
is like a mobile phone, cellular phone, what do you call it, plan. You always pay like your beginning hour, I don't know, $20. So you always like the ad is, you don't time it by X, you don't time it by anything. It's like a fixed price. So you have to pay.
Okay.
So okay, but imagine you didn't see you didn't read 64 yet. Okay, continue on,
Yeah, yeah.
and then 200 per hour after. Every time I read this, I come up with this immediately. That's why I wrote that
Okay.
immediately. But if it says just for per hour and nothing behind it, nothing else behind it, it'll be like this. It'll be 300 plus 200. X or T. Is that okay? This one they
Okay.
use T. I don't know.
So why do we end up doing t minus one?
Okay, -1.
That's what I
Now,
was trying to
okay,
understand.
now careful. I crossed the rest of them out. Is that okay? I crossed the rest of them out.
Oh, okay.
It would be without those. It would be 2x or 2t. This will be the function.
Okay.
You're done. Yeah, you'll be done for this easy problem. But okay, like 200 per hour after, like
Yep.
therefore thereafter. But it says 200 per hour. Not just that, for starting right here, for any portion of the job that goes more than 1 hour. The reason why you do a -1 because it's a rule. More than let me show you why. If now I'm just getting to basically what I've done here is basically come up with the equation, because normally that's what you do. They don't ask you 64. They don't ask you 65. No, they do ask you 65, but they basically ask you to do this right away first, like all the time. That's why I wrote that all the time. They ask you 67, and
Okay.
then use the equation to solve for the details. Like, hey, if the job takes 40 hours, this is the right order. So I think expect it to happen on the test. I don't believe they're gonna ask you exactly like this, like piece by piece. I
No,
think they're
it's probably
holding your
gonna
hands.
be
Yeah, they're gonna.
something
You have to come
similar.
up with the equation no matter what. How about that? So I think you should actually try to come up with it. So here's the explanation for it. If now I recommend you memorize it, but there's reason behind you do a -1. For example,
Okay.
if if you actually don't do a -1, let's just say you start off with this and you do 200. Let's just say just t. Okay, so if just do without the -1 or a +1, I'll even do a +1, which is not going to work either. So here, for the first hour, right? First hour, you pay 300, and then no matter what you do, you pay 300, and then the second hour, right? Let's say you do 2 hours.
Mm-hmm.
If you do 2 hours, it means that you probably want to plug in two right where the t is. It will not work. Here's
Yes.
why. If you do 2 hours, the actual answer should be 200 plus 300 would be 500. Think about it, okay? Right? Because,
Yeah.
yes, 200 per hour after, then, see the word then? 200 hours after. So it should be 500. But if you put 2 in there for t, if you make t equals to 2, it will not be true. It will be 2 times 200, which is 400 plus 3. It's no longer making sense. That's why the -1 is going to come in. But if you ask me, how does it work?
Okay.
I'll show it to you right now. But the
Yeah.
thing is that you will never actually find the -1 in the wordings. That's the only thing. You have to know it. That's all. It's just something that
Sounds
you
like
learn
fun.
from for this
Okay.
particular type of word problems. So therefore, I believe right now you probably don't care for the rest of it. You probably want to memorize it, right? So that's how I see
Yeah.
it. Yes, because yeah, it will not work. But watch, if you do a -1, it will work immediately. Here we go. Watch it. Okay, let me do a -1. T -1. Okay, now watch. If you do 2 hours, right? That's what we're talking about. If you do 2 hours, the answer better be 300 plus 200, right? If you do 2 hours,
Yeah.
because yeah. So watch. If you do t being 2 right now, t being 2, do the math. 2 -1. Here it is. It turned into a 200. Yeah, you see it? Yeah, that's why it works. That's why it works. Yeah, 2 hours. Yeah, your first hour is 300. Your second hour, 200. And then it's not just going to work for the 2 hours. It'll work for
And then if
three,
it's
4, and 5. It will continue on. So that's why this is required. So it's something you may want to learn to use for a wording that's similar to the rest of it, like this one here. For any portion of the
so
job that goes
something
more than 1 hour. Yeah, tell
So
me.
something interesting that happened is my brother just had a math test,
Mm-hmm.
and one of the questions, it was like a bonus question that on a study guide, and he was like, "Oh, I don't need to learn this one. I know I
Mm-mm-mm.
don't know how to do it, but it's just extra credit and whatever, whatever, whatever." And it was like one of these problems, and it was like this exact formatting too, and I
I'll
was like,
bet. I'll bet.
"That's
Yeah.
so weird.
Uh-huh.
This is stuff I'm learning in high school. Why are you learning
Yeah.
it? You're not even in he's in pre-algebra."
I see. Yeah, some of them they do start early. I don't remember though for my student doing pre algebra. but some teacher actually kind of instilled that in early on, in students earlier on, just in case, but
Like I couldn't explain it to him, but he figured it out somehow and got it
yeah,
on his
yes.
test. But
So
like I was like, that's the exact it's basically the exact same thing on my study guide. What the
hmm
heck?
hmm hmm so keep in mind any wording. I believe you may get this one or both on the projectile motion, like the one with the parabola, the ball throwing up. So be ready for them.
I'm probably gonna
Yes.
get both.
Yes. So fixed price, some other value, not 300, maybe $50 or maybe something else, whatever. That's on its own. And then thereafter, do the parenthesis thing -1 every single time. Anything like more than 1 hour. Oh yeah, yeah. Look for the phrase. Anything that you pay beyond more than 1 hour. Anything after that, implying that immediately do a -1. But don't forget time the number, like whatever per hour thing. Is that okay? The number per hour in front, and parenthesize it x-1, t-1, whatever. There you go. It works every single time. Now, after that, you can answer anything you want. The 40 hours, the 2 hours, whatever. See, the 2 hours, you already got it. Now, these 2 hours, they want you to come up without looking at the equation. See, it's 500. There it is. But if you use the equation, it will still work. That's why you could just come up with it right off. And then use plug in 2 instead of actually
Okay.
making sense of it. Hey, first hour is 3, and then the next one better be 2 because it says so. Every hour after, after the first hour, $200 extra.
Mm-hmm.
That's why. So, is that okay?
Okay.
Yeah. So
That
you
makes
don't.
sense.
Yeah.
Yeah.
So on the test, I don't believe. I'm like 100% sure they're not going to ask you exactly this way. They're not going to ask you, hey, first hour, 2 hours. No, they're going to
Yeah.
ask you, what is the 40th hours? That means you have to come up with the equation. They're going to ask you, what is the equation, first of all? Just like that. Yeah, because it's too much time. You don't have it. You have many other things to do. They're not going to
Yeah.
ask you. They're not going to ask you. So this is very, very common. Okay, now, at least this one quickly, okay?
Yeah. Okay.
How do you think about, is it okay for number 68? I think everything is kind of like okay, self-explanatory, but make sure you know like the max and min. Always use
So
the,
it gives.
yeah, the vertex. The
Oh, so
vertex.
all I have to do is think about it like an arc or something, and that helps me just
Yes,
realize what I
you,
need to do.
you,
Okay.
you can sketch it. You can sketch it. It will help tremendously to see whether your
Okay.
answer makes sense or not. But if I were you, whether it's going to be from the ground or from a building, use the vertex. The x equals negative b over 2a for the time where it's highest, like the highest point. Always, that's the time.
So how would I know if it was coming, like if it was like a parabola versus like one of these chart, like the chart that we drew,
Okay, it
like the
will be
full one?
something squared, something x squared, t squared. It will look just like this
Okay.
with different numbers. Yeah, always.
That's so when it looks like that with a squared,
Uh
it's
huh.
gonna be what we
Yes.
drew, and then if it's not, it's gonna be like the full
Yes.
thing.
Uh-huh. Yes. Now,
Okay.
I don't think you'll get anything else though, other than this or this. I don't. Yeah, that's my guess.
Okay.
I can't
No,
say that
I'm
100%.
guessing that too.
Yeah. So yeah, the thing about throwing or something launched in the air, well, yeah, it's always going to be something squared, and it's always going to have a negative in
Okay.
front. Always going to have a negative in front because yeah,
Okay.
the way
Let
the
me
graph
write that
looks.
down.
Yes. So look for that. Immediately start. They're going to ask you max height, how long before it hits the ground. Immediately, always. Yeah.
Okay.
All right.
Okay.
Okay.
That makes sense.
I hope you're okay. Just quickly, I never get to look over 71, 72, 73. You remember how to do this,
Okay.
right? Um.
I
Uh,
think so. It's
okay.
kind of like the piecewise functions if it didn't have
Yes.
like the rest of the stuff
Yes.
attached.
That's it. That's it. They're just
Okay.
like
That's when I get it.
one piece at a time. Yeah. I
Yeah.
don't believe you're gonna get these at all. Here's why. If you're gonna get anything related to this, you get a piecewise, one piecewise
It's
problem.
gonna, yeah, okay.
Yes, you're
Okay,
not gonna
okay,
get these.
okay.
You're not gonna get these at all.